AP Pre-Calculus. We're in lesson 2.8 on day 2. Today we're going to verify two functions are inverses of each other, both algebraically and geometrically. Just to refresh your memory, here's our formal procedure right here in 3 easy steps. We're going to jump in with example 7a. Let's say we're given f of x is the square root of x plus 3 minus 2. You can see that graph here on our grid. We want to sketch the line y equals x. I'm going to do that in red so that we have that reference for the entire graph being reflected across that line, y equals x. The domain and range for f of x, you can see that our function begins at -3, -2. So our domain for f is from -3 to infinity. And then our range for f is going to be from -2 inclusive to infinity. We want to find the inverse, so we're going to take the y and turn that into an x. And we're going to take the x and interchange that with the y. And then we're going to solve for y in terms of x. So adding 2 to both sides. And then we want to get rid of the square root. So to get rid of the square root, we would square the left and square the right. So then y plus 3 is equal to x plus 2 quantity squared. Subtracting 3 from both sides and interchanging the y equals to the correct notation, f inverse of x equals, we have half of a parabola shifted left 2 units and down 3 units. So instead of having the point -3, -2, our inverse will have the point -2, -3. And we're going to be half of a parabola for our inverse function. F inverse is in green and f of x is in black. 7b would be a great opportunity for you to turn off the video and give this one a try on your own and check that you fully understand. So we again want to sketch the graph identity function, the line y equals x. I'm doing that in a dotted red line. That's our reflection line. The domain for part B, the domain for function g is all reals. And the range for g is also all reals. In part C, we want to find the inverse. So when y is the cube root of x plus 2 plus 1, we can interchange the x and the y, solve for y in terms of x. We need to get to the cube, so to get out of the cube root, we want to cube both the left and the right to get to that argument. The cube root of our argument is eliminated when we cube both sides. Then we have y plus 2 is equal to x minus 1 quantity cubed, and replacing the y equals with our g inverse notation, we have a cubic function that's shifted right 1 and down 2. So instead of having the ordered pair -2, 1, our ordered pair will be 1, -2 on our inverse. And we have this cubic function that's going to cross on the y equals x line, just as the function did. And finally, naming the domain and range of the inverse. The domain of g inverse is the range of g. And the range of G inverse is the domain of G. So they were the same, that didn't change. Hopefully you mastered that without my help. Moving on to example 8. If a function's not invertible when an appropriate restriction on the domain is made, then we can find an inverse that is also a function. But you may have to restrict the domain in order to get a valid inverse. We know that g of x, x squared minus 5, has a domain of all reals. So already that is not an invertible function unless we restrict the domain when x is greater than or equal to -5 on the inverse. So what we're wanting to do is restrict the domain of the function, and then that will restrict the domain of the inverse. So to check that they're inverses when x is greater than -5, we want to check the g of h of x, which is the g of the square root of x plus 5. And when you substitute the square root of x plus 5 into this term here and subtract 5, we're going to end up with x. That's not a guarantee. You have to check the h of g of x, which is the h of x squared minus 5. So when we substitute x squared minus 5 into this x and add 5, we get the square root of x squared, and the square root of x squared is the absolute value of x. And then we can say, since the g of h of x and the h of g of x both equal x, for x greater than or equal to -5, we've shown that g and h are inverses. So let's just spend 1 minute looking at the graph of both of those and thinking about the domain and range. Back to g of x. If we restrict the domain of g to be from 0 to infinity, this is the g of x. If we restrict, well, the domain of h of x is already restricted from -5 to infinity. This is h of x. So you can see by restricting the domain, which is this little definition here, if we restrict the domain of g to only go from 0 to infinity, then the domain of h has a domain of -5 to 0, which is the range of g, -5 to infinity. So looking at the h graph, the domain of the h graph is the range of the g graph on that restricted domain. This needs to be a bracket. Hopefully that helps. The graph helps you understand the mathematics that we have written here. Okay, let's go look at number 9. We want to find the inverse of 2 minus x squared if x is greater than 0. First, we're going to replace the y with an x and the x with the y. Then we're going to solve for y. So y squared is 2 minus x. If we take the square root of the left and the right, we have 2 minus x. I'm not taking the plus and minus square root because they said we want to restrict the function at x greater than or equal to 0. So first things first, our f inverse function is the positive 2 minus x which means our domain is x less than or equal to 2. So you should have a piece of graph paper here. Mine's left off on our notes. But looking at the line y equals x across the identity here, this is y equals x. Our f of x function is 2 minus x squared. It's a half of a parabola for x greater than or equal to 0. And then the inverse function, we'll graph that in green. The square root of 2 minus x is going to be starting here at 2, 0, where the function y was at 0, 2. So you can see that the domain is less than or equal to 2 on our inverse. Suppose f of x and g of x are invertible functions. If f of 3 is 5 and g of 5 is negative 2, can you determine whether f and g are inverses of each other and explain why or why not? Well, we know the point 35. Let's think about this. We know the point 35 is on the graph of f of x because they've given us that ordered pair. That means the point 5, 3 would need to be on that inverse function, f inverse. But look what they've told us. The g of 5 is negative 2. So if g of x was the inverse of f of x, then the g of 5 would need to be 3, not negative 2. Therefore, we know f and g are not inverses of each other by that given information. Okay? So just being able to explain and reason in your own words is an important concept in our course. Let's look at an inverse of a rational function. If we're given this rational function and it's invertible, this is a typo here on my slides. I think your notes should be updated to say invertible. Find the domain and range of f and then find its inverse. The domain of f is going to have a vertical asymptote at negative 2. So all reals except negative 2 for our domain. And the range of f is going to have to skip over the horizontal asymptote. That looks like y equals 2 is our horizontal asymptote. So skipping over positive 2 is going to be the range. Now let's interchange the x and the y, and then we can solve for y in terms of x. Give us the inverse. So x is 2y plus 3 divided by y plus 2. We're going to multiply both sides by the quantity y plus 2. Distribute the x. Then collect like terms so that we have the y and the x on the same side. So let's think about leaving 2x minus 3 and put 2y minus xy. Then factor out the y, and we have 2 minus x coming over here. We're going to get y is equal to 2 x minus 3 divided by 2 minus x, but x cannot be 2. And then we want to get rid of the y equals and give it our f inverse notation. So f inverse of x is going to be this expression, and the domain and range of the inverse is going to be the domain of the inverse is the range of the function, and the range of the inverse is the domain of the function. And you might want to graph those on a calculator to verify that information. Our very last example, number 12. The function p of x is defined over the interval from -5 to 5, and it's shown in the grid below. Let p inverse of x represent the inverse of p, and sketch the inverse on the grid below. Is the original relation a function, and is the inverse relation a function? Well, they've told us that p of x is a function, so we know p of x is a function. And if you look at the graph, we're going to know that p inverse of x is also a function, because we can say that each element of the range of p of x maps to a unique element of the domain of p of x. So let's put that in words. Each element of the range of p maps to a unique element of the domain of p. What's the domain of the inverse? Well, let's look at the graph. What do we have? The domain of the inverse is the range of the function. So the range of the function goes from -6 on y to, what's that, +9? What is that, 5, 9? So the domain of the inverse is going to be from -6 to 9. What's the minimum value of p of x? That would be the y value at -4. So the p of -4 is the lowest value. What's the minimum value of p inverse? Well, that would be the smallest x value of the function. So that would be -4. Let's spend a minute and graph the inverse. So I have my inverse here. I'm going to label that p inverse of x. And we want to find the p inverse of 7. So the p inverse of 7, we need to look at the x value where p is 7. So what's the x value where p is 7? That looks like right here, which is 4. So the p inverse of 7 is 4. And then the next one, can we find the p inverse of -2? So we're looking for the p inverse of -2. If we come over to our graph, when x is -2, I want that point right there. So p inverse of -2. So what I'm looking at is the slope of this line. It looks like up 1, 2, 3. Wait, up 1, 2, 1, 2, 3, 4, 5, 6. So this segment right here has a slope of 1/3. P inverse of -2 is 1/3 x, and it crosses the y-intercept at -2. So if we substitute a -2 here, That gives us negative 2/3 minus 2. And negative 2/3 minus 2 looks like negative 8/3. So the P inverse of negative 2 is negative 8/3, because we were looking for the x value where P inverse is negative 2. All right. We could have done it off of here too. This would have given us negative 8/3. So negative 8/3, negative 2 is on the P function, and on the P inverse function, the P inverse of negative 2 is negative 8/3, and we see that property where the x and y's are interchanged. And that, my friends, is the end of lesson 8 on inverse functions in AP Pre-Calc.